Hi, welcome to the next part of the cache performance, and we are supposed to solve a problem over here. Let's say this is the problem, and again this is taken from some of the gate paper, so I don't remember the year gate paper, and you can expect a lot of problems from this particular topic also, cache performance. Actually, the topic cache contains a lot of questions in the gate. You can have a look. Okay, see, in the last class, or rather in the same class, in the last previous part, what we have seen is essentially this one, right? That average memory access time. What will be the average memory access time, right? So this happens to be the hit time plus miss rate into miss penalty, and the problem is based on the average memory access time. So it is given that the average memory access time for a memory hierarchy system with one level of cache and main memory is 13 nanosecond. It's already given. The hit time and the miss penalty of the cache happens to be 3 nanosecond and 100 nanosecond. So everything is given, right? You are supposed to find the hit rate of the cache. So what we already know, this is already known to you. How this has come, we have already explained, this particular section, right? That the request from CPU is coming, and irrespective of whether it's a hit or miss, this portion, the first portion, will be executed, and this gives your hit time, right? And then the next part will be done only in case of a miss, that will be driven by miss rate. And to serve a miss, the amount of clock cycles or amount of time we need to incur so as to bring things from next level of memory is essentially called miss penalty, right? So it says how much penalty do you need to give for a miss, and this happens to be a larger amount, as it is quite obvious, or you can know that you are bringing things from main memory, so you need more time. Main memory happens to be slower than your cache. Okay, so that's why you call it penalty. Now coming here rather, yeah. So this is already known to us. Now out of that, this is given, right? Hit time is given. How? Yeah, hit time is given. Miss penalty is also given, right? And you're supposed to find hit rate. From this equation, three things are given. First, let us find miss rate. So if I consider it to be a MR to be miss rate, this happens to be, I have just simply put the values. 13 average memory access time given, hit time 3 given, miss penalty 100 cycle given, or it's nanosecond given. Then the miss rate is 0.01. So that means 10% miss. If it is 10% miss, what will be hit or hit rate? 90%. How? You divide, you subtract the miss rate from 1, because 1 happens to be 100%. So this means miss rate is equal to 1 minus hit rate, or or the other way. Hit rate happens to be 1 minus miss rate, right? Miss rate plus hit rate should be equal to 100% or 1, right? So we are done with that. Very simple problem. Now let us move to performance in case of multiple levels of cache, right? So it's not one level, it's multiple level. Now then what will happen? How do you find out? So this is already known to us, that average memory access time is equal to hit time plus miss rate into miss penalty. Now if we go there, yeah, taking this one, now we don't have main memory over here. We have another memory another sorry, another level of cache over here. Now let us, what will do, this miss penalty, that means happens to be something else. What something else? The first part happens to be same. This miss penalty is again another cache, right? Let's say level 2 of cache, then the main memory. Now whatever we did here for the level 1 will be similar for level 2, right? Level 2 also a request is coming. The request is similar to a request from CPU, but this time the request is from L1. L1 is coming. Now we need to check here if the things are there, fine, give it. So this happens to be a hit for L2. If the things are not found in L2, then it comes here, then it goes. Now this happens to be my miss penalty, right? Miss penalty for L2. So if you want to say that, what will you do? We'll say this hit time will be my L1 hit time plus my L1 miss rate multiplied by the miss penalty. This miss penalty will be my L2 hit time, right, plus L2 miss rate into L2 miss penalty, right? Is it clear from this diagram? Yeah, hopefully this is clear. Okay. So if that is the case, it is already known to us. See, the miss penalty is this. So again, it is essentially introducing another level over here, right? Okay. Now I hope this is clear. Now let me give one home assignment for you with this case. See, this miss and this miss rate, where from this miss rate coming? L2, right? So this miss rate and hit rate, rather miss rate, to be honest, these are called local miss rate, right? Because local miss, the miss rate for L1 is and again we say miss rate for L2. Now, if these are called local, can you think of something called global? Or what will be the situation for global miss rate? How do you define, or like how do you say? And what will be global miss rate for L1 and global miss rate for L2? Right? So that thing I am leaving it as a thinking assignment. Hopefully you will write something on the course website regarding this. Okay, that will show whether you are going through the video or not. Okay, moving ahead, let us solve a problem. Rather, we'll be solving two problems from the multiple levels of caches, 2 levels of cache. You can go through the question. So we are given a system with 2 levels of cache, L1 and L2, just now what we have seen, and a main memory, right? Everything is given. L1, access time, so that is the hit time for L1 1 nanosecond, L2 10 nanosecond, and main memory 500 nanosecond. Hit rate for L1 0.8, L2 0.09, 0.9 is given. You are simply asked to find the AMAT, right? So we'll simply put in the formula and we'll get that. It's nothing much to do. We already have seen how this is evolved, right? Okay. This is as simple as that. Now let us add a twist to that question, and that twist was added in GATE 2004, I guess, if I'm not wrong. This is from some GATE paper. I get GATE 2004. Okay. Now see, the same thing, the question happens to be same, everything is same except the last line. You're supposed to find the average memory access time ignoring the search time within the cache, right? So we are not supposed to think about the search time. We can ignore the search time. Now what will happen? Can you think of anything? Yeah. So to address that, let us come here. So this is the situation. Let us come here. Prop 2 or other prop 3, I guess this one. Yeah. Okay. So what we are doing here is, again, two level of caches are given, L1, L2. CPU will generate request. Now what the question says, you are not supposed to consider the the search time within the cache. So is essentially is something like this. Say what happens in a normal situation, things come here, it goes through that, searches, and it is given back, right? And essentially they are saying you can ignore this one. So that means the hit time, whatever hit time they are saying, is coming and bringing back the things. So that's what is hit time. Now if you can go to the question, they are saying the first level incurs a hit ratio of 0.8, so 80% hit. So 80% of the time the things will be like this, right? So whatever is the hit time, how much is hit time is given? Some 1 nanosecond, right? Yeah. So for that much amount of time, so 80% of that time you will incur that 1 nanosecond. Now, what is the miss for this? 0.2. So 0. amount of time you will do the other way. What is that? So you come here and then you are going to the next level. Right? So whatever is the miss penalty for the next level will be for 0.2, so 20% of the time. So this hit time will incur for 80% of the time. This miss penalty for the first level will be for 20% of the time. Again, if you enlarge this miss penalty for L2, it happens to be 0.9, I guess, 90%. Yeah, 90%. So 90% of the time it will be hit for L2, this is L1, and the remaining 0.1, right, or 10% of that, it will be the miss penalty for L2. Right? So that's what it is meant by ignoring the search time. So we are not considering why it was, the in the first place it was like hit time all the cases, because we assume that everything will happen, at any case the first part happens to be same. But right now we are ignoring this search time. Right? So only 80% of the time this will happen. The rest 20% of the time it is rather this way. Right? So that will happen. Similar is the case for this one. 0.1% straight way, things will go from here to there. So this miss penalty is this one. Right? So if that is the case, now go back to our problem. So we can say that this hit time, as just explained, that it will be responsible only for hit rate amount of time, and then the miss rate amount of time the miss penalty will happen. Again, the miss penalty we can divide in the same way, hit rate for the next level of hit time plus miss rate into miss penalty for the next level. If you substitute the values, so 0.8 already explained, it is already given to you. 0.8 hit time is given as 1, right? So next, whatever comes here, this miss penalty, this is miss penalty for L1. So this will be only 80% of the time, 1 minus 0.8. Right? Again, whatever comes here, this will be for miss penalty for L2. So that will happen only 10% amount of time. Right? This 500. Right? Okay. So I hope this is clear. Now, as in the first problem, it might so happen that you are given average memory access time, and you might be asked to find out, any of the other parameters. Right? So you can expect a lot of questions from these things, both in our exam and of course in the in GATE also. So with that, let us stop today's session. Thank you.